Hello everyone. Today we are gonna talk about pricing tools and formulas and specifically looking at the framework for value-based pricing, which is in your article towards value-based pricing. We're gonna look at the company and we're gonna undertake the CVP analysis or cost volume profit analysis. And this analysis is very useful to see the so-called break-even sales change. So by break-even sales change, we want to see how much a new price will affect profitability. So before we jump in, we should know a few words, the terminology, and pretty much the message of this slide, which I will let you read autonomously, is contribution margin and contribution margin ratio. So the contribution margin just means the amount of money you make out of if you remove the cost of goods sold from your price. So let's say I am selling something for 10 euros and the cost of goods sold is 8 euros, then my contribution margin is 2 euros. And it's also very easy to see how much the contribution margin in percentage or the contribution margin ratio will be, because it will be the total contribution divided by the price. In this case, it would be 2 divided by 10 or 20%, because 0.2 is 20%. So again, if your price is 10, your cost of goods sold or variable costs, which is cost of goods sold, is 8, then your contribution margin in absolute value is 2 euros. If you want to know the percentage, you take this contribution margin and you divide it by the price. There are two ways to approach this, and you can either approach it with the sales, looking at sales, or you can approach it looking at the single unit cost, the unit price. If we move on, we're gonna see the formula, and the formula is right here in the bottom right, and it's very easy. It's 3 variables to put in, 3 numbers which you need to input, and it's even better because delta P you see in the bottom right is just the same number with a minus or a plus in front of it. So why do you use this formula? You can use it to see the necessary increase in sales in volume if you want to reduce a price. In the same way, you can use the formula to see how much volume you can lose, the maximum sales reduction you can afford if you increase the price. Because if you increase the price, you're going to make more money, so you can be as profitable as before, even if you sell less units. And that's as simple as it sounds. It's a simple formula to calculate this impact. Let's move on. Again, I will let you read by yourselves these data, these explanations, and you will also find them in your slides. Let me repeat that. I will not send slides. I'm not sending slides every day. I will send them and they will not be complete. They will not have everything we discuss in class. So you have to by yourself take notes during class. So this formula, minus delta P or minus price change over the percentage contribution margin, also called contribution margin ratio, plus delta P, again price change, is the break-even sales formula. This formula that you see right here will most likely be asked at the exam, and it will also be useful to use during the calculation, as we will see in the next slides. Please note that it's also correct to put it not in percentage, but it's going to make calculations complex, and so assume, as I will ask in the exam, as I will do in the exercise, that all of these are percentage price changes. But let's look at an actual actual example. Let's imagine you work for Alfa Romeo and you are the actual marketing manager. And in order to increase sales, you want to undertake one exercise, and you have taken the pricing course, and so you know how to use the formula. So let's say if you were to decrease the price by 10%, what would happen to profitability? Well, of course, it would go down. But you know the CVP analysis or break even sales formula, and you want to know how much you need to increase sales in order for you to be able to make it at least as profitable as before. So we have a set of data in the top right, and we want to see how to trigger this data, how to understand what is the result. So first of all, you need to understand how much is the contribution margin ratio or the percentage CM. So you know that the contribution margin is price minus variable cost divided by price. So let's go ahead and do this. So the price is X company selling price, so the former selling price, which is 20,000. Very good. You have the variable cost, which is 14,000. Okay. So divided by again the price, which is 20,000. And you also see here that you have fixed cost, and you really don't care because you're a pricing manager. The car is being produced. If you produce 1 unit or 100 unit or 100 million units, for as much as you are concerned, the fixed costs are the same. We know in real life they will change if you increase dramatically the production, if you double it. But for the sake of this conversation, and actually also for most of real life examples, real life um, things that happen, the fixed cost will remain pretty much the same. So let's try to solve this. So 20 minus 14 is 6,000. If you divide it by 20,000, you get your result, which is 30%. It would be 0.3, but that 0.3 is 30%. I'm specifying this because it's happened a lot of times during the exam that people would write 0.3 and then all of the calculations would be completely off. Even if they use the right approach, the calculations would be completely off. Okay, now we need to know the delta price. What is the delta price or price change? Delta just means change. Well, delta price is negative 10% because I'm thinking what would happen if I decrease the price by 10%. So delta price is 10%. How much is negative delta price? Well, negative delta price is negative 10%, which you will agree with me is the same as plus 10%. Why is this important? Why do I make this? Let's imagine silly specification. Why do I repeat that the negative and negative give you a plus? Well, simply because it's happened so many times that during the exam people get this number wrong. Okay, so I think we have all the data. Target, sales volume, number of units, we don't need to know that. We don't need it to solve this question. Maybe it will be useful for other things, but it's not useful for this question. Again, the fixed costs are not useful to answer this question, so you just don't consider them. Okay, so we said delta price is negative 10%, and we know that this guy solved here, negative and negative will be the same as having a plus. So to make it easy, I'm going to solve it now. The contribution margin is 30%. Okay, we got it. And delta price is negative 10%. We know that it's very easy, but it's useful to repeat that here you see plus delta price. But if you are considering a negative price change, this plus delta price will be plus a minus delta price. I cannot stress this enough. It's happened so many times that people get it wrong that I feel I have to say it. If we continue and we solve this, we will see that 10% divided by 20% is 0.5 and 0.5 is 50%. So the answer to this question is that if you decide to reduce the price by 10%, given your contribution margin of 30%, your current contribution margin, this new price will need to sell at least 50% more units in order to break even. And by breaking even, we mean in order to bring the same level of profitability as it did before. What we will do in class, and I will ask people to do it for me by sharing their screen, is to do the same calculation with the price increase. So it's going to be the same formula. It's going to be very easy to calculate, but I think that if you have the time, it's worth trying by yourself, both to redo the previous exercise, so price decrease, and to try this one, so price increase.